Hello marine engineers, welcome back to our next lectures on ship stability and construction. Next lecture is transverse stability of ship. What is transverse stability of ship? इस पे हम डील करने वाले हैं. So before going to the main technical lecture, transverse stability of ship, सबसे पहले हम बात करेंगे normal stability concept. Clear? Yes. Say.
Hi BTech marine engineering students or junior engineers, remember one thing very carefully. If you have not got campus placement as of now, नौकरी नहीं लगी है, go for BTech excellence package as of now on Merchant Navy Decoded. Link description box में invest on that, start learning. Placement 100% हो जाएगा, बस मेहनत आपको करनी है. And if you are looking at earning respect on ship, you are terrified कि पहले ship पे क्या होगा यार, मुझे डांट पड़ेगी, how will I take care of that part? Invest on junior engineering excellence package, again available on Merchant Navy Decoded. Everything out there is there which will help you get earn respect on ship and confidence as well. Jai Hind, Jai Bharat, Jai Mata.
First thing is, consider an object because of some external agency. If any force is applied to an object or if any impulse is applied to an object, if that object is coming back to its original position after performing some oscillation, is called stable equilibrium. तो जब भी हम सिंपल है स्टेबिलिटी की बात करेंगे, देन 3 कॉन्सेप्ट आपकी माइंड में आनी चाहिए. फर्स्ट थिंग इज stable equilibrium. Second one is unstable equilibrium and third one is neutral equilibrium. Clear? So first of all, what is stable equilibrium? Clear? Suppose this is my surface. Clear? I am placing one ball here. Clear? Suppose, consider if I am applying some impulse to this ball, or if I am applying some force to this ball. Now, trace the path of this ball now. Suppose I applied some force to this ball, then this ball will move like this. Agree? Clear? Means what? Consider an object. This is my ball. This is an object. No. Consider an object because of some external agency or because of some external force or impulse. If any force is applied to an object, if that object is coming back to its original position, like to and fro motion. जब भी to and fro motion होता है means what? Object अपनी पोजीशन पे कंटिन्यू at one time वो आ रहा है, अगेन वो जा रहा है, like that. Clear? So consider an object because of some external agency. If any force is applied to an object, if that object is coming back to its original position after performing some oscillation, to and fro motion is called stable equilibrium. Clear hai? Any doubt regarding stable equilibrium? Now, next thing is, what is unstable equilibrium? Now consider this kind of surface. Consider this kind of surface. Again, I am placing one object or same ball here. Now, if I am applying some external force to this ball, if I am applying some external agency or some external force to this ball, or we apply some impulse force, and if it is not coming back to its original position and it will go away from the equilibrium surface. सिंपल है. If I practically सोचो, suppose this type of surface है, clear? If I give some amount of force to this ball move like this here. Clear? This is the trajectory path of this ball. Agree with me? So this kind of system is called unstable equilibrium. Any doubt? Means what? It will go away from the equilibrium. For me, the equilibrium point is the motion of this ball in between this to this part, in between this to this part only. Clear or not? Getting or not? So this kind of motion is called, or this kind of system is called, not motion, this kind of system is called unstable equilibrium. Now, third case. Yes, neutral equilibrium. Consider surface like this. This is my surface. This is my equilibrium line. Clear? Again, place one ball here. Object here. Place one object here. Again, same object, and if we are applying some force to this object, some external agency to this object, of course, this object will move like this. This. Right? यही हो गया ना बॉल की पाथ. सिंपल है. In this case, just read this sentence. In this case, see, if the same object, if we apply some impulse force, and if it is coming back to its original pole, and if it is coming back to its original position, it will be remain within the system. But if it is not coming back, please, if it is not coming back to its original position, and it will be remain within the system, although it will be remain within the system, but this ball will not come again to its original position. Please correct it. Please correct it. If the same object, if we apply some impulse force, and if it is not coming back to its original position, and it will be remain within the system, still the ball will be remain within the system. But in case of unstable equilibrium, if we applied some force to this ball directly goes to this position. Means this ball will not be remain in this equilibrium system. But in case हम लोगों ने बॉल को फोर्स दिया, ball motion is like this. Suppose ball reached here, but still ball will be remain in equilibrium line as well. But ball will not come back to its original position. Please correct it. If it is not clear, any doubt? बेसिक्स क्लियर है. बेसिक्स है तभी हम सिप पे अप्लाई करेंगे ना. बेसिक्स क्लियर होनी चाहिए. नो. नेक्स्ट थिंग, यस, स्टेबिलिटी, ट्रांसवर्स स्टेबिलिटी ऑफ अ शिप. अगेन, ट्रांसवर्स व्यू ऑफ शिप इज नथिंग बट लाइक दैट ओनली. दिस इज माय ट्रांसवर्स व्यू ऑफ द शिप. क्लियर? दिस इज माय ट्रांसवर्स व्यू ऑफ द शिप. नाउ this point is nothing but kill. This point is nothing but kill. Right? Any doubt? Kill. This is nothing but my center line. Which line? This is called center line. Any doubt? This is my center line. This side is starboard. This side is port. Clear? This one is starboard and this one is port. Now, next thing is, this point is called B. B is nothing but center of buoyancy. This point is G. G means gravity, center of gravity. And this one is M. M is center of meta center. Clear? डिटेल्ड बाद में मैं इसको बताऊंगा. डिटेल्ड, ईच एंड एवरीथिंग इज डिटेल में बताऊंगा. सो ये थिंग्स आपको जस्ट रिमेंबर कर लो. सो फ्रॉम दिस सेंटर लाइन इक्वेशन km is always equal to this km is equal to kg plus gm. Agree? This km is equal to kg plus gm, or this km kill to the meta center. This km is nothing but kb plus bm. Agree? kb plus bm. Agree? Are you all able to relate this figure with this formulas? Correct? Yes. Now each and everything डिटेल में बात करूंगा. जस्ट मैंने आपको एक लेआउट दे दिया, आपके माइंड में ये थिंग्स रहे. Now see, so in our next lectures we will going to discuss about for small angle of stability. Clear? Like that here we discussed suppose if we applied some force to this object. Similarly some external force like wind, wave, which is continuously sometimes exerted on your ship's side, exerted on your ship. So इस केस में ship की मूवमेंट क्या होगी उस पे बात करेंगे नेक्स्ट लेक्चर्स में. क्लियर? एनी डाउट? So stay tuned for further more lectures. Thank you.